Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let us discuss part 2 of lesson 1 quarter 4, which is sampling distribution with replacement. Let us illustrate variance and standard deviation of sampling distribution of means with replacement. Example number 3. Consider a population with values 2, 5, 7, and 8. Question A. Find the population mean. B. Find the population variance. C. Find the population standard deviation. D. Find all possible sample of size 2 which can be drawn with replacement from this population. E. Find the mean of the sampling distribution of means. F. Find the variance of the sampling distribution of means. And G. Find the standard deviation of the sampling distribution of means. To find the population mean, just find the sum of all the four values 2, 5, 7, 8, and then divide the sum by the population size 4. So here is the solution. So our formula is population mean is equal to the summation of x over capital N. The summation of x is simply the sum of 2 plus 5 plus 7 plus 8, which is equal to 22. And the sample size is equal to 4. Okay, so the quotient of 22 and 4 is 5.5. 5.5 is the population mean of the given problem. Okay, next, to find the population variance and standard deviation, let us make a table of the given population values. Okay, there are 4 observations, right? Okay, the sample for the first observation is 2, second observation is 5, 3, the population value is 7. Fourth observation, the population value is 8. Okay, so let's get the sum of the population values. 2 plus 5 plus 7 plus 8 is equal to 22. Okay, so for our third column, let us subtract the population mean from the population value. That is 2 minus 5.5, negative 3.5. 5 minus 5.5, negative 0.5. 7 minus 5.5, 1.5. And 8 minus 5.5 is 2.5. Now, for our fourth column, let us square the third column. Squaring negative 3.5, the result is 12.25. Squaring negative 0.5, that is 0.25. Squaring 1.5, that is 2.25. And squaring 2.5, that is 6.25. Okay, let's get the sum. The sum of 12.25, 0.25, 2.25, and 6.25 is 21 or 21.0. Okay, so we are now ready to determine the variance. Just simply substitute in our formula. The formula is variance, or sigma squared, is equal to the summation of the quantity x minus mu squared over n. So what is our summation of x minus mu quantity squared? That is 21 divided by our n is 4 because there are 4 observations. The quotient now is 5.25. 5.25 is also known as the variance of the population. Okay? Next, to find the population standard deviation, extract the square root of the population variance. That is square root of 21 over 4, or square root of 5.25 is equal now to 2.29. Okay, so that is the standard deviation of the population. Next, for letter D. Okay, for the letter D, all possible samples of size 2 which can be drawn with replacement from the given population are listed in the second column of the table. Okay, so here we have 22, 25, 27, 28, 52, 55, 57, 58, 72, 75, 77, 78, 82, 85, 87, and 88. So as you notice, there are 16 observations because for a population of 4 raised to a sample size 2, that is 16, or 4 squared equal to 16. That is why there are 16 possible samples. Now, to get the mean of the sampling distribution of mean, let us find the sample mean of each sample in the observations. That is 2 plus 2 divided by 2, that is 2.0. 2 plus 5 divided by 2, 3.5. 2 plus 7 divided by 2, 4.5. 2 plus 8 divided by 2, 5.0. 5 plus 2 divided by 2, 3.5. 5 plus 5 divided by 2, 5.0. 5 plus 7 divided by 2, 6.0. 5 plus 8 divided by 2, 6.5. 7 plus 2 divided by 2, 4.9. 7 plus 5 divided by 2, 6.0. 7 plus 7 divided by 2, 7.0. 7 plus 8 divided by 2, 7.5. 8 plus 2 divided by 2, 5.0. 8 plus 5 divided by 2, 6.5. 8 plus 7 divided by 2, 7.5. And 8 plus 8 divided by 2 is equal to 8.0. Getting the sum, that is now equal to 88. So therefore, for letter E, the mean of the sampling distribution of means is computed as 88 divided by 16 observation, and that is 5.5. Okay, that is now the mean of the sampling distribution of means denoted by mu sub x bar. So, for letter F, to find the variance of the sampling distribution of means, let us subtract the third column to the mean of the sampling distribution of means, 5.5. So that is 2 minus 5.5, that is now equal to negative 3.5. 3.5 minus 5.5, negative 2. 4.5 minus 5.5, negative 1. 5.0 minus 5.5, negative 0.5. 3.5 minus 5.5 equal to negative 2. 5 minus 5.5 is equal now to negative 0.5. 6 minus 5.5 equal to 0.5. 6.5 minus 5.5 is equal to 1. 4.5 minus 5.5 is equal to negative 1. 6 minus 5.5 is equal to 0.5. And 7 minus 5.5 is equal to 1.5. 7.5 minus 5.5 is equal to 2. 5 minus 5.5 is equal to negative 0.5. 6.5 minus 5.5 is equal to 1. 7.5 minus 5.5 is equal to 2. And 8 minus 5.5 is equal to 2.5. Now, let us square the fourth column to get our x bar minus mean squared. That is now equal to 12.25 if you square negative 3.5. Next, the square of negative 2 is 4. The square of negative 1 is 1. The square of negative 0.5 is positive 0.25. The square of 2 is 4. The square of negative 0.5 is positive 0.25. The square of 0.5 is positive 0.25. The square of 1 is 1. The square of negative 1 is 1. The square of 0.5 is positive 0.25. The square of 1.5 is positive 2.5. The square of 2 is 4. The square of negative 0.5 is equal to 0.25. The square of 1 is also equal to 1. The square of 2 is equal to 4. And the square of 2.5 is 6.25. So getting the sum, that is now equal to 42. So let us now replace 42 in getting the variance of the sampling distribution of means. That is 42 divided by 16 observations is equal now to 2.625. Next, letter G. Let's get the standard deviation of the sampling distribution of means. Just simply get the square root of 42 over 16 or 2.625. That is now equal to 1.62. Okay, that is now the standard deviation of the sampling distribution of means. Notice that the variance of the sampling distribution of mean is equal now to the population variance over n. That is 5.25 over 2 equal to 2.625. Meaning, the variance of the sampling distribution of means is equal to the population variance divided by the size n of the samples. That is sigma squared sub x bar is equal now to sigma squared over n. Okay? Example number 4. If the sample size n is equal to 2 and the population variance is 7.75, what is the variance of the sampling distribution of means equal to? So for our solution, let's replace sigma squared by 7.75 and n by 2. And 7.75 divided by 2 is 3.875. Okay, what is 3.875? That is the sampling distribution of means, denoted by sigma squared sub x bar. Next, take note, the square root of the variance of the sampling distribution is called the standard error of the mean, or simply the standard error, denoted by sigma sub x bar is equal to sigma divided by the square root of n. A 7 example. Example number 5. If the sample size n equal to 3 and the population variance sigma squared is equal to 8.5, what is the standard error of the mean? So for our solution, let us replace sigma over the square root of n equal now to the square root of sigma squared over n. And that is now replacing sigma squared 8.5, replacing n 3, that is now 1.683. What is 1.683? That is the standard error. Okay, denoted by sigma sub x bar. That's it for now. Thank you for watching. Bye.